Good morning, guys, and welcome to today's workshop. Today I'm going to talk about DevOps, and rather than taking a practical approach, I thought it would be a good idea to go through the theory behind DevOps to have a good understanding and overall understanding. So what we are going to talk about today is DevOps. We're going to review software development methodologies and get familiar with the DevOps processes. So the objectives. The aim of this workshop is to highlight the benefits of DevOps over other software development processes, to introduce the DevOps environment, to give an overview of the different DevOps tools, and to demonstrate the process of working with a DevOps delivery pipeline. So what is DevOps? It is a set of development practices that combine software development with information technology practices to shorten the systems development life cycles. The aim is to deliver fixes, updates frequently in line with business objectives and changing requirements, without compromising uptime. Why DevOps? Developers and operations have different responsibilities. While the role of the developers is coding, testing, and packaging, operations is responsible for the management of services, servers, networks, access, and logins. Although there is a close relation between the operations, the priorities are different. On the long term, however, introducing change to the system is as important as maintaining business as usual. Now, the dependencies. Dev teams need servers and environments, so they request the operations team to provide it. Whenever development teams need change in the operation system or services, again, they need to request the operations team. Operations team needs to do a background check and not only serve the requests, but also prepare for the scenario if something goes wrong. So they have to be able to troubleshoot if there's any problem. Now that leads us to an opposite thinking. While development team requires agility, the operations team is trying to ensure that there's stability. So whenever before they grant any request, they will ask questions. Will any service go down? Will the server remain stable? Will the infrastructure remain stable? Will any networks be disconnected? And while they are thinking about this, the development team thinks that operations take time. To serve their request, and at the same time the operations thinks that the development team request had a change that they are not sure of. So there's clearly a different approach. And where can DevOps help? Well, because there's a gap, DevOps can bridge that gap, really, because there's no proper understanding between the teams and they're not working in collaborations. DevOps can provide communication and automate the processes, which will help to bridge this gap. So what does DevOps do? It integrates the development and operations teams and it improves collaboration and productivity through automating infrastructure, automating workflows, continually measuring application performance. And DevOps, well, what it is then? It's a culture change, a methodology, and a new approach. It's about understanding the different roles and how they work together. It is a continuous process and is a state of mind. Now, we're going to do a methodology review to put DevOps into context. So, Waterfall is a software development methodology that is non-adaptive methodology. If you're looking at the Waterfall lifecycle, it starts with the requirements gathering, analysis, design, implementation, and then testing, development, and maintenance. You can see that once a task is completed, the next task is following, but there is no feedback. There is no way back. So once the requirements are gathered and the analysis and the design is done and the implementation began, there is no way to go back here and add a requirement or change something in the design, because the process is already happening. And by the time it comes to testing, a lot of time passed. And the testing also comes at a stage when everything is done. So here there's a lot of bug fixing, there's a lot of issue, and a lot of headache for developers. Then there's a deployment phase and the maintenance again. The deployment is something that will take time and will have a lot of challenges. And the next picture shows how this is what I was talking about in a bit more visual way. So requirements, design, implementation, code and fixes, there's a lot of trouble here, and then finally the code is deployed and hopefully everything is working as expected. What are the challenges? From the point of development, there's a long waiting time for code deployment. Because of that, there's also pressure working on old, pending, and new code at the same time, as we talked about it before. Because the testing is at a later stage, they may be testing something and fixing something as well as creating something new parallel. So that puts a lot of stress on the development process, well, the developers really. And in terms of the operations team, it's difficult to maintain the environment uptime. There are ineffective tools for the management of the infrastructure automation, and because of the new services that are being introduced and tested at the same time, they have to monitor additional services on top of what they have to anyway. So clearly Waterfall had its or posed a lot of challenges, and in about 10 years ago IT projects, more than 70% of IT projects failed, and well, a lot of it was because of problems with the requirements gathering, but also this process is quite restrictive. As it is a non-adaptive approach, there's no way to go back. Now let's look at Agile. Agile addresses the issues of the Waterfall methodology. Here there's a planning, and after the planning there's a product backlog, which is the set of functionalities that the project wants to deliver. There's a sprint backlog, which is really the functionality that the team wants to develop in a short period of time. Usually this is 1 or 2 weeks. And once the sprint is over, it results in a shippable product increment. So what happens here, there's an analysis, a design, a build, a test, and a review. So this is the Agile lifecycle. So there's constantly a building, constantly a testing, and a review, and the product is ready. So rather than waiting for long to finally test what was designed, everything that comes out here from this 1-2 weeks period is already tested and is kind of ready to be used. So it goes through all sprints, do the same. So after each sprint, there's a shippable product, and the developers don't have to really look back. Okay, so that means that there are no build errors, and this methodology addresses the issues that we talked about, the development team's experiences, but not the issues of the operations team. So again, just briefly summarizing what we talked about. So the Waterfall methodology, you can see the systems development lifecycle, has the development, the testing, and the operations fragmented. Now if we compare Agile with that, the development and the testing is done at the same time, so that's very good for the development team, but the operations, they are still fragmented, they are separate, and at one point what is developed has to be deployed to the operations. And then here is where DevOps comes into pictures. So DevOps brings together the development, the testing and the operations as well. It allows a fast, efficient, qualitative and economical delivery via continuous integration. So what is continuous integration? So it is a development practice that requires developers to integrate code into separate repository several times a day. Each check-in is then verified by an automated build. So see, automated, this is a crucial element, allowing teams to detect problems early. Continuous integration enables the continuous deployment as the integrated component can be released faster. And let's look at this here. So it's not only developing testing, but it's also development, testing, and deployment. Sorry. So it's a continuous cycle: develop, test, deploy; develop, test, deploy. Okay. So let's now look at the DevOps life cycle. So as we talked about it, there's a planning, a coding, build, a test, then there's a release, but it doesn't stop there. It is then deployed, then there's operation, monitoring, and then it starts again with a new product that will be going through the same cycle. So rather than building something that is well defined and well documented and involves a long process, at the end of which the product might not be suitable, DevOps, extending Agile, it focuses on delivering something that is usable and deployable very fast. And how it achieves it is through automation. So these processes are automated which saves a lot of time. Now let's talk about the individual parts. Plan. So planning is probably the most straightforward. Track, visual, summarize. I also added some tools that I used in this process. Code. The coding phase is where the developers actually code. The tools use Jira, Eclipse, NPM, and then the build. It is about compiling the code and packaging. Compiling is converting source files to executables, and packaging is preparing single files ready to be deployed. Test. The process of executing automated tests as a part of software development pipeline. And the purpose of this is to uncover all the risks that are associated with the software release. Again, Selenium, Unit tools that I used in this process. And again, the automated, I would highlight that, is a crucial element of this. Because rather than waiting for something to happen, it automatically happens. And how does it happen? There is an orchestrator which brings together all the tools that are used in the different processes, and whenever a condition is filled, whenever something is delivered, it automatically moves on to the next stage, which is predefined, and just executes something that was added as an executable block. So Jenkins would be one of these orchestrators, which brings together all these processes. So yes, in this phase the code is integrated to shared repository and then to the orchestrator. Deploy. Now this is where the development teams benefits the most. Well, one of the parts. It manages and maintain development and deployment of software systems, and serves in any computational environment. For this, Ansible and Puppet are frequently used, and there's also a need for an environment, say a cloud environment, such as Amazon Web Services. Now, once the solution is deployed, then it moves into operations. So to keep the system, and that is to keep the system upgraded with the latest update, which allows the users to have fresh updates more frequently. Again, Ansible and Puppet are used here, but in this instance it's more to configure the environment where the application is running. And then monitor. So this process is monitoring the application if it is performing as expected. Again, it's an automatic process, so tools such as Nagios or Nagios monitor constantly the software and automatically detects issues and creates reports. So without any human interference, it can just do the same. And this leads. Okay, let's talk about what does DevOps involves, because although it sounds very good that there's this new process which can help. It also requires a lot of change, internal changes mainly, but cultural change, process change, technology change, automation change, and tool adoption. So there's a lot of change, which is always a risk factor. And here are the popular DevOps tools that we were talking about: version control, Git, which really keeps track of changes. Also, it allows to have previous versions and to roll back to the previous version if there's an issue. There's also a QA wall that can be built between the integration and the deployment, so nothing is released without properly testing it. Yes, so these tools, Docker and Kubernetes. Docker is responsible for docking. It's really containerization. So container is the application and its dependencies. So rather than having a virtual environment, it kind of simplifies and speeds up the processes before deployment. And Kubernetes, it's also an orchestrator, but it orchestrates between the different containers. Yeah, another tool we talked about. So let's look at the DevOps pipeline. Sorry, it's a little bit blurry, but what happens here is coding, testing, and build, deployment, release, operation. But there is always, there's always a feedback loop. So at each stage there's a feedback which can go into the coding, the next coding. So Agile would go this far, and DevOps allows feedbacks to come back from here as well, from the operations. And then let's and probably this is what sums up the best what we talked about, how these methodologies differ. So whilst Waterfall has a basic design and then a lot of coding and then a testing, deployment, things that are coded at this stage will have to be debugged, which is a much more complex job than if this is done in a small fragments. Again, by the time the delivery arrives here, the product might not even be suitable anymore. And also, this is the first point where the client actually can see the result of the development. So looking back or moving to Agile, Agile is more cautious. It wants to, after the design, it wants to have the feedback loop and implement the feedback that the client gives. So each time design, code, test, and then code test through the sprints, it delivers an increment of the product and then finally deploys. Now the DevOps, what it does the design, but following the design there is a code, a test, and a deploy stage, and it is done. Code, test, deploy. So everything that is coded, tested, and deployed moves straight into production. And rather than delivering something that is big, it delivers increments or small packages more frequently. but straight into the operations. And this is where DevOps offers something more because of the automation and because of the frequent updates and bringing together the teams. So, and lastly, let's talk about very briefly companies that use DevOps. Amazon adopted in 2010 DevOps methodology, and that was when they moved on from the physical servers to the cloud server. And about a year later, they were deploying about 1,000 different software packages into production per day. And Netflix would be another example. We all know Netflix. What is very important is that uptime. You wouldn't want to watch your favorite movie and get disconnected in the best part. So obviously for Netflix it is crucial to constantly be available, and they can manage that. If there's any problem, they can instantly roll back and just carry on with their operation without any issue. So thank you guys. Any questions?
So are you saying that DevOps is a methodology?
It is a methodology. It's a set of software development methodologies. And
is it a methodology or is it a set of methodologies?
It's a set of software development methodologies, but it brings together different aspects. So the key with DevOps is bringing together the development team and bringing together the operations, and it's pretty much the extension of Agile, in a sense that it integrates one more essential part, operations.
I agree with the statement that it's an extension of Agile in many ways, but I think to call it a methodology, and I think many of the other things that you mentioned, I would question that they may be an overstatement of what DevOps is.
So what is it then?
I'd say it's an ethos. It's really about the bringing together of development. Traditionally would have been different teams, developers, and those responsible for production and test environments. And it's an ethos around bringing those teams together so that they are able to deliver software in the way in which Agile suggests you should.
Okay, but it brings together the development, it brings together the testing, automated testing, it brings together the point. It's a set of methodologies, yeah, and they all squeezed into DevOps.
Yeah, but the vast majority of things that you put under the banner there of DevOps are an overstatement. They are not DevOps as such. They are just software development.
We are disagreeing there.
People have been testing software for a long time. It's not really DevOps.
Mm-hmm. Yes, but utilizing it.
Used as part of DevOps.
Yeah, it is.
It's being DevOps together. Obviously, you need a set of tools to enable you to do that. I think, yeah, it's sort of part of the same.
Maybe it wasn't.
So, for example, you mentioned the tool used for DevOps. It's been around for 30 years.
Yeah, I didn't say that it's only used for DevOps. I'm saying that these tools are used in DevOps. And
in real life today, when we talk about DevOps, other than fluffy words like bringing dev and ops together, what is it on the ground?
It's a combination.
It is using GitHub for shared code and shared development, then using pipeline tools like Jenkins, Service CI, whatever else. Then you use microservices or serverless infrastructure, the modern tools, and continuously deploying based on the change. So obviously there's a testing element as part of that, which will be done as part of the pipelines again.
Yeah. I guess what I'm trying to say is, I mean, I personally put in DevOps operations into 2 large investment banks before the term was coined, right? And yeah, you're absolutely right. It's about delivering software faster, delivering in an era where we don't have to shrink wrap software anymore, delivering in an era where you don't wait for 1 year before delivering software like you used to in the waterfall days. But I'm just trying to say that many of the things mentioned were a little bit more than really, in my mind, DevOps is about. I think the important thing with DevOps is about reducing the barriers between developers and those that are traditionally doing operations work, bringing them together. And I think you remember that when we talked first about Scrum, let's say, we talked about the team being multidisciplinary. That was one of the key examples, is bringing together operations and development. So
but Agile doesn't bring together operations and development. Agile brings together the development team. And Agile works on a product that has a continuous feedback, and it works on increments. So the final product is something that the client actually wants. This is what Agile is for. There's nothing to do with operations, and operations is really comes into picture with DevOps, which I was talking about. That this process can be simplified, time can be saved, and the whole process can benefit from it if operations are also factored in. Now, what DevOps does, and when I was talking about the tools, I didn't say that they were invented for this particular purpose. They are used to facilitate DevOps. So it wasn't about the tools, it was about the process, a process that uses these tools, and where these tools can offer something additional is the automation. So rather than waiting from one process and somebody to be in between to do the next stage manually, everything can be automated. So there's a process of filtering out quality issues, but once a quality issue is solved, if there is any, or a package is approved, it can automatically move on to the next stage, and everything can be automatically executed up until monitoring the operations. And whatever feedback comes from the individual stages can be built into the next start of the cycle.
There are all sorts of concerns, right? Obviously, so that talks about building, testing, deploying on a continuous basis. Two of the classic examples that Amazon and Netflix deploying to production every couple of seconds, basically, as new features come in. So, and people talk about DevSecOps nowadays, DevBizOps, right?
Yeah, DevOps, there's design ops, everybody is putting ops on the end of every phase.
The bottom line is, you want to go from your requirement to production as quickly as possible, while being secure, while being quick, while delivering, making sure you haven't broken anything. And obviously there are a few other things that you could do with mentioning, like blueprint requirements, canary requirements, or things like that. There are different models, right, to how granular you can get down on that. But yeah, so it's all good stuff.
So guys, thank you for your contributions. We're a bit out of time.
Thank you guys.
Yes. Thank you very much, Dave. Thank you for the introduction to DevOps. I would like to add a couple of things. I'm not going to enter on this discussion, but regarding to what you explicitly mentioned, so do you mind going back? I don't know what it was. When you talk about the beginning, we got devs, we got testers, we got DevOps, and now we got like everything all together. Yeah. that one, right? So the reason why I would like to focus on maybe 1 minute, and that's, I find this slide particularly interesting, right? For you, for your future. Historically speaking, and I agree on that, right? So the roles were very well defined. It was, hey, he's the developer, the tester, it's separate tables, right? In separate rooms, right? Roles were very strong, right? I'm not even talking about UI, right? And all these guys on the left-hand side, very strict roles. This is changing, yeah? And that's probably the second and the third row on this slide. And the reason why this is changing is because, obviously, I think we'll agree we want to release more often. The more we release, the better. The only way to make sure we release more frequently is making sure that the developers, they understand how DevOps work, right? Because historical problems is DevOps was a bit disconnected from development or vice versa, right? So now, in other words, the trend, as some of you mentioned, is developers getting more and more involved into the DevOps world. Why am I saying that? Because at some point, you'll become really good developers. You'll know how to do array.filter, .reduce, all these things. Yeah? This is happening already. But at some point, you like to progress, right? And you will see that the natural way to progress is to, I'm not sure if that's the correct word, cannibalize, right? To take responsibilities that, historically speaking, belong to the other guys, right? So the first natural step is going on the left, which is UI, right? Some of you are saying, hey, I need to improve my CSS. And directly, what you are saying is, I would like to work a bit more on the left, right? I would like to do what the classic designers have been doing. But also, of course, it works on the right-hand side, right? Testing, that will be vital. If you want to join companies like Sky, you need to be really good at testing. TDD, BDD. Because of these sort of things, starting from April, you'll have a React, right? Because with React training, you'll be doing proper testing. Yeah. And of course, and it goes without saying, the DevOps side, right? So we need to make sure when you do npm run build, you remember that? This is one of the first steps of DevOps, right? As they've explained before, we are creating a production-ready bundle. Yeah. This is probably one of the entry points of DevOps. What's your artifact? Yeah, that's npm run build. Yeah, so in the long term, you will see that you will start, touching not just the dev column but everything, and it will happen on the other way around, right? More and more testers, they are doing development. DevOps, they are doing development. UI guys, they are doing development as well. So it's a mix, right? It's not just you are going to do everything, right? But to me, and that's a personal thing, starting with the dev thingy, which is what you are doing, is good, because to me, personally, I find this is the most complicated one. Yeah. If you know coding, to me, it's much easier than to learn testing, to learn DevOps, to learn UI. If you know any of the others, at some point you have to learn coding, which could be a bit more challenging. Yeah. I give always the example of Codery. It took me like 2 months to deploy Codery to AWS, using load balancers and good infrastructure, because I'm not a DevOps person. It took me a while, right? But still, it works. I managed to solve the problem. I don't think a DevOps person will be able to build a platform like Codery without technical skills, yeah? So that's why, in my opinion, dealing with dev as a first step is a good starting point, personally. I have nothing against DevOps. I'm sure that if I took 2-3 months, DevOps may have taken like 1 week, right? But anyways, what it is, right? You can progressively learn DevOps easier than coding, in my opinion. And one more thing, do you mind, Dave, going to the right-hand side when you explain a bit about tooling? It was, move on to the next slides. Keep going, please. A bit more. It was maybe before. I don't know. When you talk about Jenkins and all these sort of things. The one. Oh, that was the one before. Yes. Well, actually, there was another one before, but that's fine. Okay, let's say that at some point you want to get into DevOps, right? To me, that I personally find this stack a bit disconnected from what you'll be doing, right? Things like Jenkins, right? Jenkins is, I don't know, maybe 30 years old, right? Still, if you join, especially big bank, In large corporations, they still may be using Jenkins, but that's not the common thing. If you join a startup, if you're in a new tech company, they won't be using Jenkins for sure. They will be use cloud-based continuous integration solutions, right? And I'm talking about, I'll give you a couple of examples, just in case at some point you want to say, oh, how DevOps works. I would like to investigate and to get a better understanding about these things, right? So probably the most, or two of the most popular platforms talking about DevOps at the moment are Circle CI and Travis. You may have heard about both, any of them, right? So they are pretty similar. Essentially, they are online platforms, so you don't have to install anything. So that helps a lot in your infrastructure. Yeah. So essentially, you set up some config files in your project, and then running some commands, you deploy the project to the cloud, right? So what are these tools doing? They are running the test. They are making sure that your code is elegant. You remember the elegance console? They do these sort of things, right? So for instance, if you are trying to push any function with more than 10 lines, reject the commit. Yeah, you know, this sort of things, right? They control the quality. They have a bunch of steps, and they control the quality. Run the test, they, linting, elegance, concatenating, minifying, all these sort of things, right? So again, Travis and Circle CI. I particularly like Circle CI because it has a free plan. So if you want to start, playing with DevTools, to me, is the best way. Yeah? Because it's very limited, but still, just to get used, to get familiar to different steps of DevOps. Correct. Yeah. That's the thing. Yeah, that's correct, Bala. So if you start working with Travis or Circle CI, immediately you'll notice you have to deal with GitHub hooks. So a GitHub hook is a mechanism that whenever you are trying to commit something to GitHub, GitHub can send a notification to the continuous integration tool, right? As I said, git commit. Then Git will send a message to the continuous integration tool, say, hey, this guy is trying to commit. Please run the test. So if one of the tests fails, block not the commit, the push, right? Block the action. Yeah. Hooks. HOOKS. Yes. So they have pre-push hooks, post-push hooks. For instance, you want to send an email whenever someone pushes new code, right? So between GitHub and these CI tools, you can do that, right? Yeah, that was pretty much it from my side. Anything else?
I mean these tools are just representative. Obviously, they are not the only ones. I just wanted to give a selection that kind of fits all the individual parts. And going back here as well, just 1 second about that. Here, what I wanted to demonstrate is really the difference between the methodologies. So before testing, between development and testing, there's a kind of a disconnection. Everything has to be developed before it is tested. Whilst with Agile, the testing and the development goes hand in hand, and then moving on. So this is what I was trying to show with this, really. But yeah.
There is a classic job interview here, when they ask you, can you tell me the classic development process? And the classic answer is, okay, you do the development thingy, and then you test your code, and then you deploy it, right? Do you think is there any better answer to that? You can say that, but Sky is not going to hire you, right? So the ideal answer is not I first do the coding and then I do the testing. It's on the other way around. You first test and then you write the code. And then it's a bit mind-blowing, right? How can you test something that doesn't exist? Yeah, but this is how it works. It's TDD. What TDD means, guys? Test-driven development. That's correct. Test-driven development. Test-driven development means you first write the test. I'm going to create a function called validate email. So if I pass a valid email, the function returns true. If I pass an invalid email, it returns false. Yeah? You write the test, but the function doesn't exist. You haven't created. This is a coding challenge. It's a training. When you do training, on the left-hand side, you got the test. Yeah? Short array. You got the test, and then it's up to you to create the logic. So you've been doing TDD, even if you probably weren't aware about that. Yeah?
That unit testing, I mean, that's been going for a very, very long time. We're not talking about this is an agile thing.
No. Wait, so one thing is the technical aspect. So unit testing has existed for decades. But what is relatively recent is when and how do you apply unit testing, right? The reason why now we do tests, or we should do tests before writing the code, is because the community has proved that if you do the test first, your code looks better or looks more precise, because you are forced to test all your functionalities. So you'll think twice before adding a new thing. I know this is oversimplistic, and someone on YouTube may complain about that, but this is the way it works, right? It has proved that doing the test first helps. And if you do a quick search on Google, you'll get more details, right?
By the way, this has also been around a very, very long time. But I would agree that it's becoming more in fashion, in play now. But it's been
Yeah, absolutely.
People go a step further and do README-driven development. Seriously, because obviously, because you need to document your, say, GitHub repo or particular module, for example, right? So you write README first.
Yeah.
Exactly what you're expecting that module to do.
Yeah.
Then write your test based on your
Yeah.
description there, which then means that you haven't missed anything. You state what your aim of that module is.
Yeah.
Then you write test-driven again. README drives the test drives the development.
Yeah.
So Ricardo, are people like Sky seriously doing that? Because I know it sounds great in principle, in theory it's great, but I've seen relatively few examples in live industry, in our industry, that actually do it on a day-to-day basis.
Yeah, they do. Yeah, and at least at the time I was there, I was mandatory. Yeah, if I was pairing with someone, they had to do TDD. Yeah, because it clearly helps. And the recommendation, because I understand the first time you do TDD, it's like, this is a waste of time. This doesn't work. This doesn't make any sense. But the community says that even if at the beginning you find it weird, because it is weird. Just wait. Be patient, because one day it will click right in your mind, and you will realize that that was actually the best thing to do. Yeah. So don't try to find the benefits of using TDD on the first day, because I think that never happened. But if you keep trying, one day you'll realize why this is so beneficial. So yes, I agree with you that I think the majority of the community says, I know TDD is great, but in reality, yes, a small portion of the community is actually doing TDD. But that doesn't mean that if you want to join a specific type of company, you should not only say TDD is great. They assume you are going to say that, but you should prove that you can do TDD, right?
Even automated unit testing.
Yeah, exactly.
Doesn't happen as much as it should.
Agree. Yeah.
But if you don't do it, continuous delivery and deployment is a no-go.
It's a no-go.
Definitely at scale.
Yeah.
So, because it's all automated, you're not relying on people. So you've got to write them.
Yeah. It's a classic problem on when you do a job interview. What do you think about TDD? Yeah, that's great. Oh, fantastic. Can you do it? Yeah, but you should be consistent. If you defend it, you should be able to play with it. Yeah. And one last thing regarding TDD. Starting from probably summer, one of the changes we are going to introduce in the platform is you'll be able to submit new training exercises. Yeah. So submit new training exercises. That means you'll have to do TDD. Yeah. Because you'll create the questions. I want everybody else in the Codiri community to create a function to validate the email. So you create the test cases. You see, that's TDD. You create the problem, and then someone else, could be you yourself, of course, but afterwards, timing-wise, will create the function validate email. Yeah.
Is it only with JavaScript? Like
No, of course, no. TDD is...
What if I don't use JavaScript, just the front end? I mean, without JavaScript, just CSS.
Yes. Well, doing unit tests with CSS could be a bit challenging, even though still technically speaking possible. But there are other ways to test, for instance, CSS, right? Even though that goes a bit beyond the scope of the session. When talking about DevOps, we evaluate the different types of testing. Generally speaking, the first thing we test is our unit logic, unit testing. That's essentially a coding challenge. I invoke this function and I expect to return that if the argument is this. I invoke the function again and now the function should return something else if the argument is different. That's unit testing. Once unit testing is sorted, there are different type of testing called functional testing. Functional testing means there is a browser, could be fake or could be real, and we have an algorithm that clicks around on the screen. So for instance, a classic example, login. We want to see if because of our change, we are breaking the login system or the sign-up system, which would be a big problem, right? So we have a mechanism that automatically adds a username, password, types enter, press enter, and if the URL redirects to the home page, then the login was correct. If you saw an error, the login was wrong. You know, this kind of testing, yeah? We also talk a lot about mocking. So stabbing. So we have the front end, we have a back end. Are we invoking the real back end? Are we creating a new user every time we try the functionality? Yes or no? All these things. Talking about CSS, there is something trendy now called visual regression testing. That's a very sexy topic. So visual regression testing means I got my app, like your team app, right? Whatever it is. And now I want to see if someone else by mistake is, for instance, changing the background color. If someone breaks it. How do we test that? That has been pretty much impossible, historically speaking, to test the visuals of your app, right? You can test the components, but not the snapshot, how the app should look like, right? So now with visual regression, and there are some tools to do that, like Backstop.js, what you can do is you can take a screenshot of your app, like a proper screenshot, like when you take a screenshot of your phone, right? Okay, this is my homepage of my 8 days a week, coin analysis, whatever. That's my homepage. Please make sure that whenever someone commits, you know, tries to merge something into the app stream, then take a new screenshot and compare them. They should be the same. If the screenshot differ, for instance, if your background color is blue and by mistake I change it to green, then fail. Reject it, or at least alert the team. Hey, wait a minute. Someone is trying to change the background color. Maybe that's a genuine change, right? Maybe that there is a task to change the background color, but maybe he did that by mistake, right? Changing the CSS. So visual regression testing helps you to compare screenshots. Very trendy. Backstop.js, if anyone is interested.
People do regression as part of CI. Do they do load testing too?
Yeah, they do, but obviously load testing generally tends to be on the side because if you run a load test as part of the pipeline,
Cool. Anything else, guys? No? Cool. Thank you very much.